In this video, we're going to take a look at hexadecimal color choices, which are fully supported in matplotlib/Seaborn and give you, the analyst who's making a graph, a lot of flexibility and customizability in terms of the colors you can use in your plots. So you may have seen these before. And for instance, if you saw 81 D8 D0, okay, well, that corresponds to Tiffany blue. But why? Like, what's going on with that number, and why does it give us this particular shade? Well, for every hexadecimal color choice, there's 6 values that define it. The first 2 define its redness, the second 2 define its greenness, and the last 2 define its blueness. So that there are 256 possible shades of red, 256 of green, and 256 of blue. And that doesn't sound like a lot of colors. But it doesn't really. But when we multiply those together, we get something pretty large. So among friends, we're just going to say this is 16.7 million plus unique values. And that is what makes hexadecimal color optionality really special. And okay, but what are those values, and why, how does 81 give us some amount of redness and D8 gives us some greenness? Well, we have to just look at each one of those color pairs on its own. And within each one of those pairs, each one of those 2-digit values, the rightmost digit is the ones place, and the leftmost digit is the 16s place. So if we take, let's say, for instance, let's look at this 81 right here for the redness of Tiffany blue. There's a 1 in the ones place, so that's just 1. And there's an 8 in the 16s place. So we need to do 16 times 8. That's 128. And then we just add the 1 in the ones place, and we get 129. So from this, on the spectrum from 0 to 255, there's 129. We could think of it as redness units. And let's look at some other pairs and sort of think about or see how the hexadecimal value corresponds to a decimal value. So FF is the largest possible value for any one of these individual colors in the hexadecimal system. And it corresponds to 255. But why? Okay, well, the leftmost digit in that pair is an F. And that F is worth 15. And so 15 times 16 gives us 240. And the rightmost digit is also an F, and that's in the ones place. So we just multiply that by 1. We sum those 2 values together, and we get 255. And the letters may seem strange, but to just explain what's going on with those, the number values 0 to 9 are very straightforward. Those 0 to 9s in hexadecimal they serve the same purpose as 0 to 9s that we see anywhere else. But the problem is we run out of unique values once we go above 9. So what do? We use letters as a stand-in. And the values of those letters are shown here. We start with A, which corresponds to 10, and that goes up to F, which corresponds to 15. Let's just play around with a couple other pairs, and then we'll get right to it and we'll try some combinations in a graph. So what about A9? Well, we'll use the same process. So the leftmost digit in the pair that's going to correspond to 10. And we know that from right here that A is worth 10, and that's in the 16th place. So we multiply that value times 16, we get 160. The rightmost digit is 9, so that's just 9 times 1. We sum them together, and we get 169. Okay, let's try another one, 6B. So we have a 6 as our leftmost digit. 6 times 16 is 96. B times 1, that's 11. And we know that from right here. We sum those, and we get 107. Next, we'll bring in Lobster 23. Lobster 23 is a data set that has information about each day of Lobster Land park operations from the 2023 season. And we've got a bunch of variables here. One that we can look at is, we'll look at, say, unique visitors. And what we can do, and I'll start with the default actually before we even give it a color value. So I'm going to say, what if we wanted to just build a histogram, a basic histogram in Seaborn to see the distribution of unique visitors? We can do that And this exact shade, this particular type of blue, that's just the seaborne default. So that's what we're always going to get if we don't specify a color. But if we want, we can do something else. We can give this value here, and we can get, ta-da, this cool shade of Tiffany blue. And we can change that too. The sky's the limit in terms of what we can try. So imagine if we said, let's crank up the redness all the way. We'll go with no greenness, and we'll crank the blueness up as high as it can go. So we're mixing pure red and pure blue. And what do we get? Purple. And then we could also do other stuff. We could say, all right, well, how about let's take the greenness all the way up with the redness, but we'll take the blueness away. What do we get? Yellow. But we don't have to just go with these extremes. We can try things that are somewhere in the middle. Suppose maybe we want to try some redness, a decent amount of redness. We could do something like that. We could go with, say, a little bit less on the greenness, and then we'll take the blueness down even further. And let's see what that gives us. It's sort of like this brown kind of looking shade. And we can just go from there. I mean, we could say, okay, but what if we decided we wanted something a little more blue? So we crank this up a bit, and then we want to say, okay, let's turn the redness down some, so we can give this. We'll take this digit here down a few spots, and we get this very different kind of purple than the one we saw earlier. So the thing is, color matters, right? It is important. Colors can be associated with a brand. It can be associated with a logo. It's part of a marketing strategy for any company to really get the color scheme right. And so what we encourage you to do, try some of these on your own, and you don't have to just do it manually. If you Google the phrase hexadecimal color picker, you can find a lot of tools online that will let you explore and just use sliders and drag things around, find a shade you like, and then know what those values are and use it. But really, the major goal of this video was just to get you to see that when you see hexadecimal colors, that is not just some haphazard collection of letters and numbers, but it is actually something very specific with 2 digits corresponding to redness, 2 to greenness, and 2 to blueness. And we hope you enjoyed this video. Thank you for watching. Don't forget to like and subscribe, and have a great day. Thank you.